Hello, Mr. Anish. Today we are going to talk about graphs. So, I would like to start my presentation with your introduction.
Hello, hi, Priyadarshi. This is Anish over here.
Okay.
Yeah, so start.
Okay. Today, for my DSA project, I would like to start this presentation of graphs. So, I'd like to tell about algorithms in graphs. Okay. So for example, like how a problem can be modified into a graph. So we are going to start with this introduction and then we are going to start about some examples. Okay. So let's say if you are a milk vendor, so you are going to pass this milk into every street. So for this problem, you are going to okay, these are the places 1, 2, 3, 4, 5 you are going to visit.
Okay.
And you need to visit a particular place only once. And you should
Okay.
not visit the same place again and again.
Okay.
This is the problem. So that means each place can be modified into a vertex.
Correct.
And the distance between your place vertex
Okay. Okay.
and the distance between you and the vertex can be considered as an edge. So you need to visit a particular vertex only once and you should not visit the vertex and second time or third time, more than once.
Okay.
So this circuit can be called as Hamiltonian circuit.
Okay.
A particular vertex should be visited only once. So likewise, a simple problem can be modified into a graph and we can solve this problem with respect to the graph.
Okay.
So now you can think of something like when you want to travel to a place. So you'll use your Google Maps. For one place to another place, you can have multiple crosses, multiple paths. Let's say this is path 1, this is path 2 or path 3. But you'll
Okay.
choose the only one which is of shortest distance. Your
Okay.
Google map will show the distance which is of shorter path
Okay.
compared to all the distance between each vertex.
Okay.
So what's the logic behind that? So we're going to talk about this. So let's say you are at this vertex 1
Okay.
and you want to enter to 6 and you want to travel to 6.
Okay.
And there are multiple distance between 1, 2, 3, 5, 6. So you need to identify the shortest distance from 1 to 6. How can you do that? So there is an algorithm for this. This algorithm is called as Dijkstra's algorithm. So how you are going to solve this problem? So if you are at vertex 1, let's say you are at place 1. And for place 2 and 3, you are having two options. From 1, you can go to either 2 or 3. What this algorithm says is that for a particular vertex, if you are standing at a particular vertex, you need to choose a distance which is smallest compared to every other vertex. From 1, you are having two options. Either you can go to 2 or you can go to 3. But if you compare the distance between 2 and 3, 2 is the shortest. That means this distance is the shortest.
Okay.
So you will take this 2.
Okay.
And every nodes will be updated to infinity. So first you will update every node to infinity and then this 2 is smaller than infinity. Correct?
Okay.
So
Yeah.
in that case you will update this infinity to this nodes, to this value, distance.
Okay.
Similarly, if you go to 3, still this 4 is smaller than infinity.
Okay.
So you will update this infinity to 4.
Okay.
Now we are having this option. That means for a tooth vertex and this third vertex, you are having this 2 distance and 4 distance.
Correct.
So among 2 and 4, which is the smallest one? Your 2.
Correct.
So you will take this 2. Now you will update everything from 2. Now from 2 you can go to 4. Now you will add up these two. which is your 2 plus 7, your 9.
Okay.
So 9 is less than infinity, so we'll update this infinity to 9.
Okay.
Now here from 2 you can go to third vertex with a distance of 1.
Okay.
Now in 3 you are already having 4, which is
Correct.
updated from 1 vertex.
Yeah.
Still this 2 plus 1, which is your value 2 plus 1, 3 is less than 4. So
Correct.
now you can update this 4 to 3.
Okay.
So now if you see here you are having 9 and infinity, infinity, and again you are having 3. 3.
Okay.
So now you can from third vertex you can go to every other vertex.
Okay.
So from 3 if you see 3 plus 3 is 6. 6 is less than infinity. So you'll update this infinity to 6.
Okay.
Now your 4 is already updated to 9.
Correct.
Now here 6 and 9, if you compare both, 6 is less 6 is a smaller vertex.
Yeah.
So now from 6 you can go to this particular 6 vertex with the distance of 5.
Correct.
So now you are having 11, which is less than infinity. So I'll update this infinity to 11.
Okay.
Now if you see this 9 and 11, 9 is the vertex which is of smaller length. Sorry, this 4 is the vertex of smaller length 9
Correct.
compared to 11. So you'll take this 4 and from 4 you can go to 6 with a distance of 1.
Correct.
So you'll update this 11 to 10.
Okay.
That means from the vertex 1 to vertex 6 you can go with a distance of 10. So this is how you can solve all the problems related to distance, and you can identify the shortest distance among every vertex.
Okay.
I hope this is clear to you. Okay. Thank you. I'd like to end up this presentation.
Okay. Thank you.
Okay.